Hi everyone. So today we're going to be going over circuit diagrams, what to expect in drawing circuit diagrams, how to read them, as well as power in circuits. How do you calculate power in circuits? So to start off with circuit diagrams, basically here is the here is a pretty simple circuit. We got a battery, a resistor, and a switch. And there you go. I just close the switch. That gets the current, closed loop, and now current is flowing. But what would that look like? Instead of, it's a bit of a pain to have to draw out a battery and all these wires and draw out the resistor and draw out the switch and everything. Is there a simple way that we can do this? Yes, there is. There are circuit diagrams, and so I'll show you. If you didn't see over here, there's a little icon in the lower right corner of the screen that I can switch to the circuit diagram. So there you go. That's what the circuit diagram looks like for this circuit. So I'll open the switch. There you go. The switch is open. So that's the diagram for a switch. Kind of makes sense. For a battery, it's these two parallel lines. So diagram for a switch is right there. Diagram for a battery, two parallel lines. One is greater than the other. The bigger line means it's the positive terminal of the battery. The shorter line is the negative terminal. And then you've also got resistors right there. And they give you a bunch of other a bunch of others right there. Okay, so I'm just going to quickly go over what those are. So for a battery, again, it's just two parallel lines. One is bigger than the other. This is the positive end. The longer line is the positive terminal of the battery. The shorter line is the negative terminal of the battery. You don't have to write those positive or negative signs, but just to kind of show you that. Resistor is just a line, and then just a couple squiggly lines. There you go. Light bulb, this is kind of a lot of, I've seen many different ways to do this. I tend to stick to a resistor or a resistor with a circle around it. Switch is just an open part like that. So there you go. There's your switch. And I also wanted to bring up a capacitor. We're not going to talk about capacitors too much, but a capacitor is two parallel lines that are equal in size. So that means a capacitor. Again, we're not going to be dealing too much with capacitors, but I thought I'd bring it up. All right. That brings us then on to power. How do you calculate power in a circuit? Well, let's see. What the heck is power again? Oh, that's right. Power was the rate of change of energy in a system. So it's the change in energy of a system over the change in time. So when we're talking about electricity, what kind of energy is being changed when we're talking about electricity? Oh, I know. That's the electric potential energy that's changing. So I can replace that. So that means the power is equal to the change in electric potential energy over the change in time. And I seem to recall that actually a voltage, an electric potential, is the amount of electric potential energy per charge. We've talked about this. And so I can multiply both sides by the charge, Q, and I get that the voltage times Q is equal to my electric potential energy. Well, I'm going to use that and actually plug that in for my electric potential energy here, because something kind of fun's going to happen. So my power is equal to my electric potential multiplied by the charge divided by delta T. Hey, wait a minute. Q over delta T, we've learned that. What the heck is Q over delta T? The amount of charge over time. So the rate of change of charge. Oh, that's right. That's current. Current is Q over delta T, the amount of charge divided by the change in time. Well, then that means that power must be equal to the voltage multiplied by the current. And that is how you can calculate power on a circuit. You take the change in electric potential, multiply it by the current going through that potential difference, and there you go. That's the power there. Now, you also can actually apply Ohm's Law. The voltage is equal to the current times the resistance. and get simpler. You might not know the potential difference. You might not know the current or something like that. So you can actually use Ohm's law to say, let's say I don't know the potential difference, and I wanted to calculate power, but I did know the current and the resistance. Well, this is the potential difference here. I can plug that. Basically, I'm going to plug this in there, and that would give me the power is equal to, well, IR, so it's going to be IR times I. Oh, so that's just going to be the power is I squared times R. That's another way you can calculate power. It's the current squared multiplied by the resistance. Or I could do the same thing, but instead of saying V equals IR, I'll say I equals V over R, and take this and plug it in for my current, and that'll give me power equals the electric potential multiplied by the electric potential over R, or that power is the electric potential squared over R. That's another way you can calculate power. Typically, we stick to V equals IV, or power equals IV. We stick to that one. But you can use any one of those other ones as well, as their nice little shorthand. But really, it's just plugging in Ohm's law into the power equation. So there you go. All right. Hope that helped. Bye.